Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Izwan bin Muhammad Noor, Namometric FA18022. Today I want to present about dynamic spring balance. For introduction, a spring is an object that can be deformed by a force and then return to its original shape after the force is removed. The force exerted by a spring is called the spring force. If X is positive, the resulting force is negative and vice versa. In other words, the spring force always acts so as to restore mass back toward its equilibrium position. The elasticity is a fundamental property of the wire that the spring is made from. A long straight metal wire also has the ability to spring back following a stretching or twisting action. Next, objective. Spring balance is used to measure the weight of the object. When a load is hung on the spring, it stretches and the spring's extension is proportional to the weight of the object. Okay, this is apparatus and material. Okay, first material we use is knurled nuts. The quantity is used 14, and so this is the picture of the knurled nuts. Okay, second is wake hook. We only use one. That is wake, which is load. We use one set. Next is spring balance. We use 100 Newton spring. Okay, for the procedure, we have three tests in our experiment, which is test one is tension. The tension spring was attached from the hook. A wake hook was hung on the lower end of the spring, and then a piece of plain paper was tapped on the mounting panel so that the bottom of the wake hook is near to the top of the paper. Okay, we can see in the figure. I will show you later. Next is the level of the wake hook was marked on the paper with a pencil. And next, 100 Newton of load. 1 Newton of load was placed on the wake hook and new level was marked at the wake hook. So is a weight beside the mark was recorded. 1 Newton of load was added gradually and new level gets marked. The step is repeated until 5 Newton and the result was recorded. Then load of 1 Newton will be removed at a time and the level wake hook at each step was marked until all loads have been removed. Okay, so this is the figure I want to show you. Okay, which is the spring. Okay, this is the spring, and you see load over there. We use spring 0.009 millimeter. Okay, we see 0 Newton. We have 0 meter. For 1 Newton, we have 0.003 meter. For 2 Newton, we have 0.008 meter. For 3 Newton, we have 0.012 meter, and 4 Newton we have 0.016 meter, and lastly 5 Newton we got 0.019 meter. Okay, so this is a graph for test 1. We can see here. Okay, first for result test 2, we also use spring 0.009 millimeter. Okay, for 2 Newton, we got 0.006 meter. For 4 Newton, we got 0.013 meter. For 6 Newton, we got 0.019. 8 Newton, 0.027 meter. And 10 Newton, we got 0.034 meter. And so this is load. The graph load versus elongation, we see increase there. Okay, this is result for test 3, which is compression. We use a 0.008 millimeter spring. Okay, for 1 Newton, we got 0.001 meter. 2 Newton 0.003 meter, 3 Newton we got 0.005 meter, 4 Newton 0.007 meter, and lastly 5 Newton we got 0.009 meter. Okay, so this is the graph load versus elongation. We also got increase. Okay, for this discussion, so this is the question is calculate the spring constant value k without using f equal to kx. So here we have to use the gradient formula, which is m equal to y1 minus y2 over x1 minus x2. Okay, for test 1, increasing load, we have to substitute 0.015 minus 0.075, and we got 0.0375. For test 2, also same formula we use, and also test 3 we use the same formula. Okay, for the next discussion is explain why springs are usually used in building weighing device. The answer is the predictable and repeatable way in which springs stretch in response to applied forces will provide a method for measuring weight and other forces. Furthermore, spring can be designed to produce conveniently measured stretch distance for a wide variety of force. And spring also follow Hooke's law, which states that the restoring force. Okay, lastly is conclusion. In conclusion, after completing all of these lab tasks in accordance with all the prescribed procedure, we have succeeded in achieving what we want to achieve, which is to verify that the extension of a coil spring is proportional to the load applied and to show the principle of a Hooke law. That's all. Thank you.